Okay, we have already discussed what the domain and range is. Yes, right now we know that x values are domain and y values are range. Okay, x values domains and y values range. So this is domain and this is range. Another important point is that let me show you 1, 2, 3, 4, and 5, and this is A, B, C, D, E, F. Yes, right now, if you see such an function, as you see here, this element F is alone here, uh, and if you see such an function, it is one to one. Okay, and if you see no F, if you see no F, that time there is no any element on set Y remaining alone. That time we can say that yes, it is one to one and on two. This situation is one to one and on two is very important. It is a very important situation because then I'm going to explain you that if when I'm going function is one to one and on two, we are going to say that function of that function. So being one to one and on two is very important in details. Once again, let's check the questions once again. Okay. The following is the domain of the function. If you see use our domain, okay, x value. If you are asked to find the domain for that function, it means that you are going to find the by looking at the x-axis. So yes, x numbers for the and finishes with 7. But be careful. Circle. If you see such a circle, defining this point is not on the set. In other words, doesn't include function doesn't include this number. Point minus 3 and 2 is not in our domain interval. It is not in our domain interval. Okay, and same as here, 3.3 and 0.3 and 0 is not in our domain interval. But 7 is okay because, as you can see, this circle is full. So we can say that our domain is start with minus 3 and goes through 3. Start with minus 3 and goes through 3. But minus 3 and 3 is not in our domain. So if it is not in our domain, we are going to show it like this, with that bracket. Okay, with that kind of bracket, it means that minus 3 and minus 3 and 3 is not in our set. And at the same time, if you see such a symbol, it means that or. So in other words, it means that set two different sets is an union set. So yes, once again, one of our domain interval is that one, and the second one is 3 and 7. But 7 is in our domain. So I'm going to show its bracket like this. You can also show it. You can also see that explanation in options. X is greater than minus 3 and less than 3, or x is greater than 3 and greater than equal to less than and equal to 7. So you can also see in definition. Okay. That's why option D is true for this question. Okay, this is another question type. I'd better focus a little bit more. Okay, this question is about the translation of a function. Okay, yes. When you look at the first function, minus x, minus 5, minus 3, 0, and 4, these are all x-intercepts. In other words, these x values makes the function 0. These values make the function 0. And when you look at the other function after transformation, each number goes 1 unit to the right. Okay, so if you see such an equation and assume that this is the function f(x), that time for each unit transformation to the right, you need to subtract it from x value. That's why your new function is f(x minus 1). But I better explain you the transformations of functions. First of all, option B is true for this question, no problem. But let me show you in detail. Okay, let's look at the transformations of function. Okay. Yes. This is xy coordinate plane, okay? And a graph like this, and your function is f(x), okay? One unit to the right, okay? 1 unit to the right. That time, your new function is f(x) minus 1. This is your new function gx after transformation. 1 unit to the left, and that time f(x plus 1 is your new function after transformation. 1 unit up, that time your new function is fx plus 1, and your new function is gx right now after transformation. And 1 unit down, that time your new function is fx minus 1, and it is gx after transformation. Okay, in general we can say that b units to the right, fx minus b is new function gx, and b unit to the left. So yes, it is fx plus b, and your new function is gx once again, and b units up, so fx plus b is gx, and b units down, that time fx minus b is your new function gx. Okay, this is the general transformation rules. This is the general transformation rules for functions. Okay, beside it, sometimes you are asked to find the reflection of the function. They can also ask you to find the reflection of the function. So I better explain it once again. Okay. Yes. This is your function. Assume that it is a linear function. Okay, this is your linear function fx, and if you are asked to find the reflection of that function to y-axis, reflection for reflection for y, and that time it means that each point is going through the other side. Okay, let me show you. Yes, this is the point here, this is the point here, this is the point, and this is the point. Then you can realize that this is your reflection. Okay, and this is the function f, sorry, this is the function g, reflection of fx. Okay, gx is reflection of fx right now. Okay. Okay, so what about reflection for x? Reflection for x, and that time by using the same method, you are going to move each point. Here, and here, and that time your new yes, this is your new function, and assume that this is function hx is reflection of fx again. Okay. So what about their equations? Okay, let me show you with a real example. Then you can easily understand. Okay, yes, this is our graph. Why? I'd better choose a simple question, simple example. X plus 1. Okay, let's draw it. This is our xy coordinate plane. Okay, this is x plus 1. This is the x plus 1. Okay, we see that y is 1 and x is minus 1. Okay, 1 and minus 1. Okay, this is our graph. Y is x plus 1. Okay, let me show you the y reflection. Let me show you the reflection for y axis. Okay, this is the reflection for y-axis. That time, just a second. Okay. Yes, we know that that part is 1 right now. Okay, so yes, our new line is, as you can realize, just a second. I'm going to show you with the equation x over 1 plus y over 1 is minus 1. So yes, y is minus x minus 1. Okay, this is our equation for that reflection. What about the other reflection? Let me draw it clearly. Let me write it clearly. Okay. Our reflected line is right now minus x minus 1. Okay, this reflection is for y-axis. Okay, so this is the reflection for x. Okay, that time minus 1 plus y over minus x minus y is minus x plus 1. Okay, so can you realize is your if your function is f in reflection for is the and assume that this is g, is the minus fx, and fx or x-axis, and that minus x. So as you can, in other words, minus x minus 1. Okay, so this is the another rule for this is the another important rule to find the same rule for each function. If you want to find the reflection of a function for y-axis, multiply with minus x, and if you want x variable, minus x. Okay. So let's check this question. Realize it's a quadratic function, and we are asked to find its function. And probably this question gives us the intersection point. As you can realize, it is minus h in bracket square. So we know that for that form, parabola is tangent to x-axis. Okay. Yes, we are sure that it is tangent to x-axis. But what about its shape? When we look at this sign, it is minus in front of the equation. That time we can say that the shape is concave down. Okay, the shape is concave down. Okay, if the shape is concave down, let me show you. Let me show you that. In addition to this, let's find the x-intercept. Okay, to find the x-intercept, I need y is 0, so minus x minus 3 in square. In other words, x minus 3 is 0, so x is 3. Yes, we can easily realize that x intercept is greater than 0, so it's going to be on the positive side of x. That's why option A or B is true. That's why option A or B is true. Yes. And also it is concave down, so option B is true for this question. What about this question? Okay, when we check this question, just a second. And we check this question. Okay, a graph drawn in the coordinate system which is scaled in 1 unit is represented above. Which one of the following is the equation of the graph? Okay, when we look at this graph, we are asked to find the equation of the graph. You can easily realize that it is the rational function. It is an exponential function. You can also think it 2 or more units up. For instance, you can see it's like this. You may see it like this. So yes, it's an exponential function. And when you look at the options, yes, each option is an exponential function. But you need to define the whole equation. Yes, to be honest, you can check each option, no problem. As you can realize, there is a translation, there is a transformation. Okay, there is a transformation for that graph. Your first choice, you can try to find the transformation, and then you can check the real function, or you can only take 2 points. For instance, first one is 0 and minus 1, and the second one is 1 is 0. Okay, or you can check each point for each equation, and then you can realize which one is true. It's up to you. I'm going to show you the two-way. So let's check the first way. Yes, let's check for the point 0 and minus 1. That time minus 1 is 2 to the power 2 to the power 0 plus 2. Yes, you can easily realize it is not true. Let's check the second option. Yes, for 0 and minus 1, minus 1 is 2 to the power 0 minus 2. Yes, it is okay. No problem. Let's check for the other point 1 and 0. Okay, that time 0 is that time 0 is 2 to the power 1 minus 2. Yes, it is also okay. So probably option B is true, no problem. But let me show you other options at the same time. Okay. Okay. For that option, 2 to the power, just a second. Okay, let me show you for point 0 and minus 1. For point 0 and minus 1, minus 1 is 10 to the, sorry, 2 to the power, minus 0, minus 2. Okay, this is okay. And that time 1 is, and 1, just a second, sorry. 0 is 2 to the power minus 1 minus 2. You can easily realize it is not true. That's why option C is not true for that two options. Okay, you can also check the other ones. Option B is true, no problem. But you can also solve this question. You can also solve this question by defining the transformation. Okay. Yes, we can easily realize that. We can easily realize that. Base is 2. Okay, base is 2. So, yes, no problem. Base is 2. And it is original. It is original. Graph is like this probably. 2 to the power x. Okay. 2 to the power x. And 2 point down. So if your function is 2 to the power x, and the transformation is if the transformation is 2 units down, that time if the function is fx and it is 2 to the power x, that time you need the transformated function as fx minus 2. In other words, 2 to the power x minus 2. You can also find the transformated function like this. Okay. Okay. Is there any question? Can everybody understand?
Yes. Yes.
Okay. Okay. Thank you. Okay. Yes. Let me show you another question. Okay, this is another question. You can also check this one because we have already studied the similar one. What about this question? Okay, when we look at this question, yes, for that kind of questions, you are going to take your points or values from graph, then replace it, then you are going to try to solve the final calculation. Okay, so we see that x value is minus 4 for function f. In other words, just a second. In other words, just a second. We have 9 minutes remaining. Okay, so yes, h is minus 4. In other words, f. Yes, in other words, it is f4. Okay, because the minus 4 in absolute value is 4, no problem. So yes, f4, we are asked to find the f4. So for f4, this is 2. Yes, we can say that this is 2. This is the value 2. What about g2? So what about g3? Okay, g3 is f3 plus in absolute value f3 over 5. Okay, in other words, f3 is 0 and this is also 0, so it is 0. Okay, so it is 6. 2 times 3, the calculation is 6. Okay, solution is 6. So, yes.
Well, I didn't understand that one.
Sorry?
I didn't understand that question.
Okay. Okay. Yes, as I told you, yes. When we look at that explanation, rather than x, for instance, function hx is f in absolute value x. So, you're going to see that you can extract each value from fx, then you can transform it to gx or hx. Okay, so let's start from fx. When you display each function in terms of function f, you can see such an equation. Let's try to find the function h minus 4. So h minus 4 is at the same time f in absolute value minus 4. But in other words, there is an absolute value in as minus 4. It is at the same time 4, so minus 4 is that for the value x is 2, because function and x as display as the variable. So 4 is 2. In other words, h minus 4 is also 2. Can you understand? Okay. And the function g an absolute value fx over 5. Yes, and here x, your y value is 0 because point x is on that is 3, 0. That's why it means that 0 plus 0 over 5, it is also 0. Okay, let's try to find g minus 4 plus g3. Yes, you are going to see this, so it is finally 6. Could you understand?
Yes.
Okay. Okay, I think today is we have completed. Try to solve your homework, and please check these questions. You are going to see another translation. There are good questions. You can really benefit from them. And if you can't solve answer later, yes, probably tomorrow we are probably math. It's up to our work schedule. I can balance it. Okay.
Yes.
Okay. We can balance it. See you tomorrow.
See you tomorrow. Bye. Bye, sir.
See you tomorrow. Bye. See you tomorrow. Bye.
Bye, sir.